Hi, this is Lori, and this is my homework for Paul McWhorter's Uno R4 course. This is for lesson 28. We're bouncing an LED around the LED matrix that we have on our Uno R4. And this lesson is a precursor to making our own Pong game that we'll use on the LED matrix. Now, I did a bunch of these homeworks at Camp Failure, but the weather got a little cold, so it wasn't a good place to record the lesson. So a bunch of these will come out. I'll probably release them a couple days apart so I don't overwhelm everyone with too much homework at a time. And I will say I really struggled with this lesson and the Pong lesson. I was kind of trying to do them together. And I kept getting a very strange error, and it made me think that something was wrong with my Uno. And then I really found out, as usual, it was what was wrong with my code. So I'll point out where I went wrong and the lesson, the error that I got, because for me, I mean, now that I look back on it, I think it does tell you what you need to know, but I'd never seen this error before, and I was a little afraid that something was wrong with my Uno, because I do know they can be a little sensitive, and I have heard people say that they've had them die on them, so I started to think that something had happened to my Uno, and I didn't have another one to test it out, so but no, it was just bad programming on my part, and so I'll tell you a little bit about it and how I resolved it. But it did, unfortunately, take me several days to find the error in my way of thinking and the way I did the coding. All right, so this is how I approached it. I actually wrote this down on a piece of paper, and it's exactly the kind of thing that Paul keeps encouraging us to do. Luckily, I approached it that way, so I felt like I've been a good learner. And I started by drawing out a hypothetical path for my LED to be lit. So here's our LED matrix with the rows and the columns numbered as they would be in any kind of coding that we would do. And then I said, what if the ball started here and it went this way, and then it hit this wall, and then it went this way, hit this wall, then it would go this way, hit a wall, go back, and bounce. I figured that was enough bouncing to kind of try to figure out how I wanted to program it. And I had read a book on very simple game programming a while back, and so I had a rough idea that we would need to keep track of the direction that we were moving both in the X and Y. And I tried to think of this as rows and columns, since that's how this matrix is addressed, rather than like an X and Y grid. Doesn't matter, but that I just forced myself to think in R and C rather than X and Y. And then I said I knew we would have to have some sort of direction. So these are, if you're into mathematics, then you're thinking about vectors, right? So first I just said, okay, what if we started here at 3, 3, and then we would move here to 2, 4, and there 1, 5, and 0, 6, and now we've hit a wall in the R in the rows. So I'll mark this. Okay, we hit a wall in the R direction, and we need to flip the R direction. Don't have to flip the C direction, but we need to flip the R direction. So I started off, the direction for R was going down in rows, and we were going up in columns because we're moving this way in the column space, and we were moving this way in the row space, and that's how we got to this wall. And then we'll flip the R direction instead of going -1s, so taking away 1 every time. Once we hit the wall here at 0, we'll start adding to the rows to start going up in rows to bounce the Pong. And so we keep the column direction the same because we didn't hit a column wall. And you can see as we bounce around, we'll hit a wall and we'll flip directions, hit a wall, flip the appropriate direction, and that'll get us around. So once I had written this out, I had a pretty good idea of how I wanted to program it. All right, so this is the error I was getting in the way I program it, and I'll show it in the code too, where my thinking wasn't complete enough for it to work correctly. But I got this pretty strange error that I had never seen before, and in fact, this firmware name pointed to a sketch that I had run, I don't know, maybe a couple months ago. So it started to make me think that my Uno was not working appropriately, or the data had become corrupted. And you see it says bus fault is caused by imprecise data access violation. Now, now that I know this error actually tells me a little bit about what I was doing wrong. And what it was the way I was moving the LED around. When I started, I could move in a direction that would go outside of the frame, and I would get numbers outside of the nice little frame that we have. And interestingly enough, it wouldn't fail sometimes immediately. It would fail several moves outside the frame, and then this error would come up. And of course, it didn't happen all the time, because how it worked was when I started right on the edge, and the first thing I did was move in a direction that would take me out, I didn't have any way to check for that. And the way I'm lighting it to avoid rewriting the frame all the time and making it complicated, I could set the initial direction such that I could then move outside the frame, and it would never stop because it would never bounce up against another wall the way I'd written the code. So that's the gist of the error I had. But it was tough because it would only happen when my little ball would start on an edge, because I was randomly choosing my starting location and my directions, and it went only when the direction would get flipped and take it outside of the frame. So it's just a thing I learned, that I think when you get this kind of error, what you have to ask is, am I accessing some kind of data space that I haven't defined? And I mean, I don't know, you may get this error from other things, but that's how I was getting the error, was accessing parts of the frame that I hadn't set up. I wish I had gotten a little more help with the error, because I felt like that wasn't something that certainly a beginner is going to pick up on. But this is the kind of error I would get when I would go outside the frame and try to light LEDs that were not set up by me, and obviously didn't exist. So that's the gist of what I did wrong. All right, so as you can see, I ended up with 3 versions. Some of that was different versions trying to find out what I was doing wrong. So this is the final one that has the fix. And you can also see on here, flip this around, I've added a potentiometer to my circuit so that I can adjust the speed of the ball sort of dynamically, rather than having to change it within the program, because I thought that was kind of fun add to do to it. So that's what the potentiometer is for. All right, so let's look up here, and we'll get our matrix going, and then we need to set up the variables. So like I said, I used R and C to describe the 2 positions. So I have the R position, the C position, the R direction, and the C direction. And then as I was trying to figure out how could I randomly choose the direction, a -1 or a 1 for each of them, I saw that people, when you have something that, you couldn't just say choose this range. So if you have numbers that aren't necessarily, connected to each other, I said, how do you do that? And I mean, there are probably some other ways that we could have done this, but you can just put all your choices into an array, and then you can randomly select, you could choose a random number to pick the index, and then you can get the value that goes with that index. So that seemed to be the easy way to do it, and that was a nice little thing to learn. So that's how I did that. Then we'll just set up our initial frame, and then I need to set up the potentiometer as well. So I'll put that on a 0. I'll have a value for the speed, and then a value for the potentiometer reading, so a variable for that. I mean, And then we'll set everything up, set up our potentiometer, start our LED matrix. And then here's where I'm setting the random directions. And this is this is where I went wrong, because I was letting it start on edges. So to solve it the way I had chosen to program it, the simplest thing for me to do was just not let it start on an edge, and then my loop would work correctly. So you can see I'm not starting on any boundaries by the way I'm choosing my random number. And then here's how I pull out one of the directions for both the row and column. And we'll start the serial monitor so we can print the speed to the serial monitor. In the loop, first thing we'll do is set the speed. So we'll read the potentiometer, and we'll use the map function to take the potentiometer value to the speeds that we want. So the slowest will be 500 milliseconds, half a second, and the fastest will be 10. And this is where you could adjust it if you wanted to choose different ranges of speed. We'll print that information to the serial monitor. And then we'll turn on our first LED that we set back up here in the setup loop. And we'll turn that one on, and we'll send that to the matrix. We'll render that, and we'll set our speed. Then we'll look to see, roll that up here, we'll look to see if we've hit a boundary. So if we're on one of the boundaries for the row, we'll flip the row direction, and if we're on one of the boundaries for the column, we'll flip the column direction. So that's pretty simple. And then we'll turn off our last position on the frame, and we'll update our position, and when we get back here to the top of the loop, we'll then light the next LED and render it. So that was how I got around like redoing the whole frame again. I think that's kind of how Paul did it. I did it a little bit different, so I just had to turn off the last one and turn on the new one. So that was my approach. All right, so I guess it's time to see this go. Okay, so let's give this a go. I've got it set up. I know the lighting is not great. It's really bright in here, and I'm actually got this thing shaded about as much as I can without moving my studio to some other room. And I don't really have a studio. I have some ring lights, but I get a lot of light from the windows, which is great for working in here, but not so great for controlling all the lighting. So I'm kind of at the mercy of whatever the weather is. So for looking at this matrix over here, it can be a little hard to see, but hopefully you're seeing the ball move around here. And I've got it on the slowest speed. So you can see here in the serial monitor, it's at 500 milliseconds. And we'll speed it up, maybe go about halfway. And let's see, yeah, we got it almost halfway. And you can see the bouncing ball is moving much faster. And let's take it up a little bit more. Maybe we'll get it to about 100 here. There we go. That's 100. Oh, that's a little bit better. That's about how I can play when I do the when I do the Pong game. I can stay and play with that kind of speed. Now let's speed it up a little bit more, and yeah, that would make it pretty challenging. That's what, 16 milliseconds. And then let's go all the way. And I'm just looking down at my monitor, and you can kind of see it's a little more obvious in life that you know, as it moves around that fast, it can't quite turn off all the lights fast enough, or they still, you know, show up as you are looking at it. So you get kind of a trailing view of it there. But that's how I put it together, and I want to thank Paul for this great lesson. I learned a lot because of the errors I was making, how to be careful and notice when you're working with something you haven't defined properly. And yeah, I want to thank you all for watching.